Mais uma intervenção, vamos agora ouvir falar de Fossa Systems, a pioneering Portuguese and Spanish satellite manufacturing company. É com o Julián Fernández, CEO da Fossa Systems.
Thank you very much for the introduction. I'd first of all like to apologize for doing this presentation in English. I've heard that most of them have been in Portuguese. I'm very sorry for that. I could have done it in portuguese, but for the best of both, it's probably best if we do it in English. So my name is Julián Fernández. I'm the CEO at Fossa Systems, which is a startup dedicated to democratizing access to space and telecommunications. And I'd first like to start with a little bit of the pitch of exactly what Fossa does before going into today's sort of mini masterclass on space. So 80% of the planet has absolutely no connectivity. We take out our cell phone here or in Lisbon or in Porto and we have absolutely no problem because we're connected by cellular systems all over these urban areas. But the reality is that 80% of the surface has absolutely no coverage, and this includes maritime areas. Population, not so much. 99.9% of the population is to a certain degree connected, especially in countries like Portugal, Spain, which have very dense networks. But again, in surface, this doesn't occur. And nowadays, there's an increasing number of IoT devices which are being deployed in remote areas, industrial companies which are deploying devices and assets in remote areas. We're talking anywhere from a pipeline to a cow that is in remote areas. And there's a need to monitor these assets to know exactly what is occurring. So what Fossa does is it's launching a constellation of small satellites in low Earth orbit. We've already launched 20 to connect these assets directly using low power IoT devices that collect this information. So the topic of today is going to be new space and the new space paradigm. What exactly is this new space? There's a new space agenda. This morning we were hearing the Minister of Defense talking about new space. We're hearing about the Vice Chief of the Air Force hearing about new space and how this is important for sovereignty. What exactly is new space? So here we have to differentiate two main areas. Although traditional space companies don't really like this naming, it's going to help us to understand. On one side, we have the more traditional companies like Thales, Airbus, let's say long-term companies that have been working on satellites. And on the other hand, we have new space companies, which have been doing a more, say, agile way of developing space. So when you think of a satellite, you think of a very large device manufactured by NASA, by ESA, something which costs several hundreds of millions of euros, and which has been developed for dozens of years in a clean room. One example of this is the Ingenio satellite. It's an Earth observation satellite that was developed in Spain a couple of years ago. It took 10 years to develop. From the first day until the last day, 10 years. It cost 200 million euros. By the time they launched it into space, the technology was already outdated. They launched it into space and the satellite blew up. Fortunately, this was a problem due to the Italians. They mixed some cables, the satellite blew up. But think about this huge investment that was made into one unique asset, nearly like a work of art. New space, on the other hand, is the use of off-the-shelf technologies, COTS technologies, the same technology that you have in a mobile phone or in a laptop, applied to a satellite in a much more agile fashion, also in size. Unfortunately, I didn't bring a satellite with me, but they're very small. They're about the size of a mobile phone. And instead of satellites being the size of this stage, nowadays you have satellites the size of a shoebox or even of a little mobile phone. And so new space is this new paradigm of being much more agile, using COTS technology. Instead of launching one satellite, you can launch 20 satellites. Instead of investing 200 million, you can invest 20 million in 20 satellites, which are not going to replace the traditional satellites, but which are going to be able to complement them. So the other question is, why space? What exactly can we do in space? You know, there's a lot of investment in space, but what is the true use behind space? And here there's certain boxes of use cases that you use in your daily life. One of them, I'm sure you know, GPS. This is within the navigation box. Nowadays, satellites are used for GPS through triangulation, but they can also be used for aviation with a system you may know called ADS-B. ADS-B is a system of beacons installed on airplanes that transmit a position for ATC to know where that aircraft is. MH370, a very unfortunate accident, was over the Pacific Ocean when it lost coverage of any sort of ground radar or ground ADS-B, and it was lost to never be found again. If there had been an ADS-B satellite over this aircraft and an ADS-B transmitter, you would have had a full track of where that aircraft was outside of ground coverage. There are other systems like AIS, which are applied to boats, to tracking where these boats are. And these satellites can be placed to receive information about where these boats are, where these airplanes are in remote areas, besides providing the position, navigation, and timing, which is what we all know as GPS. Other box is remote sensing. You've all opened Google Maps. You have fantastic image of satellite image. You can see your backyard, exactly where it is. So this is, let's say, the most common application of Earth observation, but there are many more, like synthetic aperture radar. Instead of taking images with a camera, with a multispectral camera, you can use a radar to transmit a signal to the ground, receive the signal back on the satellite, and you can see through clouds. Take images of the ground through clouds. This has tremendous capabilities for defense, tremendous capabilities for looking at ground leveling, for analysis of the ground. So SAR is a fairly recent Earth observation technology. There's another one which is the electromagnetic spectrum, what we call signals intelligence. Photons are on the electromagnetic spectrum. When you take a picture, that's on the electromagnetic spectrum. But RF waves, what we transmit from our mobile phone, from our radio, from an illegal fishing boat, these are all radio waves which can be tracked and identified. And you can detect, analyze, and geolocate these RF signals in what we call signals intelligence. These satellites can carry very intelligent radios, which can geolocate these signals and tell you, hey, there's an illegal boat off the coast here in an area we don't recognize, or there's a mobile phone which is emitting here, or here in the border with another country, we have someone using a MAMPAC system. So these are some of the applications which we have around positioning, around Earth observation, and then we have comms. The comms we know, Starlink, for example, which has revolutionized connectivity as we know it on the battlefield. In Ukraine, this has been a system which has shown tremendous potential for connecting assets in remote areas. And then we have other systems like IoT, which is where Fossa is working. Not connecting to Netflix or to Google, which is what Starlink is doing, which is broadband communications, but just a tiny little bit of data. Say, getting data from a cow to know what position is it at, what is the coordinate, latitude and longitude, what is the temperature of the cow, or what is the heartbeat of the cow, or from a pipeline, being able to understand what is the voltage of the cathodic protection system. Do we need to go and change the rectifier on the pipeline? We have a customer in Spain, Exolum, which is a national oil and gas operator, and they have 4,000 kilometers of pipeline throughout Spain. And so they have cathodic protection points every kilometer that induce a voltage in the pipeline to reduce corrosion. So this is a very big infrastructure, but it can be extrapolated to really any utilities, any water management, electricity management, any of these use cases. So they need to send out an operator to go with a multimeter and measure each point. Why not install an IoT sensor connected via satellite for these remote areas to be connected and send every day a message of, okay, my voltage is 28 volts. You no longer need to go and take the measurement. You're reducing emissions on the operations of having to send someone out there. You're reducing operational costs. You're increasing the quality of the data. You're improving the latency at which you receive information from this infrastructure. So these are the use cases in which Fossa works. Fossa is deploying a network of satellites in low Earth orbit. We have already launched 20 satellites in low Earth orbit that have provided and are providing IoT connectivity in these remote areas. We're deploying a network of 80 to provide worldwide real-time coverage. And this will allow very low power devices, which are powered by a little battery, the same battery you can have in your remote, to send a byte or a couple of bytes of information to a satellite every day to know, how this asset is behaving. These satellites are in LEO. It's important to understand LEO, which is low Earth orbit, which is beneath 1,000 kilometers. So traditionally, when you think of satellites, you probably think of your parabolic antenna to watch TV. Many of you probably have parabolic SAT TV or parabolic internet TV. These are fixed antennas that are pointing towards the equator, where you have fixed satellites. LEO satellites don't work that way. There's an analogy that I like to explain. let's take the Earth as a potato and the satellite as a potato peeler. So a LEO satellite is a potato peeler that is going around and that is continuously carving at the potato, and the Earth rotates. So the potato is slowly turning, and you slowly cover the whole potato in a full rotation. LEO satellites travel at 27,000 kilometers per hour. They do 15 orbits of the Earth every day, so they see the whole planet. Even with one satellite, you see the whole planet, but you need a big network of satellites to cover the whole Earth. That's why Starlink has thousands of satellites, and Fossa needs a network of 80 satellites in low Earth orbit to be able to track the whole world at any time. So GEO satellites, 36,000 kilometers, LEO, more like 1,000 kilometers. They're closer, they're cheaper to launch, they're easier to launch and to put into orbit. So this is a bit about new space paradigm, about satellites in LEO, in GEO, and the different applications. Fossa is a company that was founded in 2020. We're currently based in Madrid, and we're also based in Tagus Park in Oeiras. We recently opened our office there, which has been developing R&D for satellite payloads and IoT devices. We are carrying out a large investment in Oeiras to manufacture these satellites and to produce and register these satellites in the future, not only in the field of IoT, but also in other fields, as I was saying, like signals intelligence, SDRs, or Earth observation. Other fields of IoT, like 5G NTN, which are also being looked at. And we believe that we can revolutionize the way that businesses, corporates, are monitoring their assets worldwide via satellites, with two different business models. One business model is more of a software as a service, where we deliver a connectivity service to each user. This is more like with NOS, for example, you pay every month 14 euros to connect your phone. Well, you pay every month 2 euros to connect your pipeline, to connect your cow, to connect your individual asset, and you use the Fossa constellation. But we also provide dedicated networks to customers. We have launched satellites for customers like Microsoft, dedicated satellites that provide a service only to a customer. So it's realistic that nowadays, for 1 million, 2 million, you can have your small constellation of 10, 20 satellites in low Earth orbit to deliver your own IoT connectivity service, something that would have been unimaginable 10, 20 years ago. And that's thanks to the reduction in prices due to new space, due to SpaceX that have reduced the price of launches, due to COTS technology, all of this new space paradigm. So this is all regarding Fossa, regarding our technology and what we intend to do. I thank you very much for listening to this presentation. And if you do have any questions, please feel free to let me know. Thank you very much.